to take a look at linear equations in two variables. And we're going to start here with a definition of the coordinate system. So if we take two number lines and join them together at the point 0, we get the xy coordinate system. This point of intersection, 0, 0, is called the origin. And inside of our xy coordinate system, we have two axes. We have the x-axis, that is horizontal, and the y-axis, that is vertical. These two axes intersect in such a way that we create 4 quadrants, and we label them like this. This section up here is called quadrant 1. If we move over to the left, we get quadrant 2. If we move down, we're in quadrant 3. And one more step to the right gives us quadrant 4. Every point on the xy plane can be plotted with what we call an ordered pair of numbers. So I've put an ordered pair down here, 3, comma, minus 1. Now each number tells us a little bit of information. The first number, which is usually called the x-coordinate, tells us how much we move to the left or right on the x-axis. The second number, which is usually called the y-coordinate, tells us how much we move up or down on the y-axis. Now it's important here to note that the order of our coordinates is important. For example, the ordered pair 3 minus 1 is not the same as the ordered pair minus 1 and 3. Let's plot the ordered pairs 3 minus 1 and minus 1, 3. For the ordered pair 3 minus 1, the first number tells us how many steps to move in the left or right direction, depending on whether it's positive or negative. Since the first number is positive, we're going to move 1, 2, 3 steps to the right. And since the second number is negative, we're going to move 1 step down. And to plot our point, we will just put a little dot here, and we could even label this as the point 3 minus 1. For the point negative 1 and 3, we begin again at the origin. And our first number tells us we need to move 1 to the left. The second number tells us whether or not we move up or down. Since it's a positive 3, we're going to move 1, 2, 3 steps up. So we'll put a dot here, and we could label this as the point negative 1 and 3. One reason for us to utilize the xy plane is it allows us to study the relationship between two variables. So in the following few lessons, we're going to be studying linear equations in two variables, otherwise known as lines. There are two different ways that linear equations may come at you. The first way is standard form. This is a times x plus b times y equals to c. A, b, and c will be filled in with numbers. The second way you might see a linear equation is in what we call slope-intercept form, or y equals mx plus b. Here, m is equal to the slope of our line, and b is equal to the y-intercept. But more on that later. If we're given an ordered pair, we can determine whether or not it is a solution of our linear equation by performing a substitution. So remember that our ordered pair comes with two numbers. The first number is the x-coordinate. We're going to substitute this value in for x anywhere we see it in our linear equation. And our second number is the y-coordinate, and we're going to substitute that in for the value of y anywhere we see it in our equation. For these types of questions, since we don't know if the ordered pair is going to be equal to the right-hand side, we'll form a chart. We know that the right-hand side is equal to 0 no matter what, so I'm going to put that into our chart under RHS. For LHS, this means the left-hand side, we're going to perform the substitution of x is equal to 1, so 2 times 1, and y is equal to 2. And we're going to evaluate this to see if we get it equal to the right-hand side. So indeed, we do have 2 minus 2 for 0. So we might conclude by saying that the left-hand side is equal to the right-hand side, so the ordered pair 1, 2 must be a solution to our linear equation. Let's say we have a line drawn in the xy plane. Wherever this line crosses the x-axis is called the x-intercept. So in our particular graph, we can see right here on this red dot is where our line crosses the x-axis. Notice here, if we were to describe this as an ordered pair, we would have some kind of movement to the left, but no movement up or down. So we might say that the y-coordinate of our x-intercept is y is equal to 0. So this gives us a strategy for when we're trying to calculate the x-intercept of a particular line. If we do have the formula for our line, what we do is we set the y-coordinate, or the y value, equal to 0, and try to figure out what the x-coordinate is of our ordered pair. So setting y equal to 0 in our equation gives us 0 equals 3x minus 6. We can move the 6 over by adding 6 to both sides of our equation, and we have 6 equals to 3x, and in our final step we're going to isolate x by dividing by 3. So here we're going to get x is equal to 2. Now be careful, the x-intercept is not x equals to 2. That's the x-coordinate. The x-intercept is an ordered pair. So in our question, we might finish by stating that the x-intercept is the point 2, 0. Let's do one more example where we have the line 15x minus 3y equals to negative 35. So we're going to use the same strategy. If we'd like to calculate the x-intercept, we're going to set our y-coordinate equal to 0. That means we're going to sub in y equals to 0 here. Notice that 3 times 0 is equal to 0, so we're going to be left with 15x equals negative 35. And we could go ahead and divide both sides by 15. And all we have to do is just simplify our x-coordinate just a little bit. It looks like we can divide both the numerator and denominator by 5. That'll give us 7 over 3. This means that our x-intercept must be negative 7 over 3, comma, 0. We could also define something called the y-intercept. If we have the graph of our line, we say the y-intercept is wherever our line crosses the y-axis. In our particular example here, down in the bottom right, our line crosses the y-axis somewhere around here, so that's the point where we would call the y-intercept. Notice that the y-coordinate of this point would be non-zero. There is some movement downwards. However, there is no movement of this ordered pair to the right or to the left. So the x-coordinate of our y-intercept is equal to 0. Similar to what we saw earlier, this is going to give us a strategy to calculate y-intercepts. If we want to calculate the y-intercept, we're going to set our x-coordinate equal to 0. In this example, if our x-coordinate is equal to 0, we get 2 times 0 minus 7, or y is equal to minus 7. Remember, this is similar to what we saw before, so y equals to minus 7 tells us the y-coordinate. It doesn't tell us the y-intercept, which must be an ordered pair. In this particular example, we might say that the y-intercept is the point 0, negative 7. Now remember that this form is called slope-intercept form. Here we have that the y-intercept is 0, negative 7. And up here we also have the value of negative 7. So if you do have something in slope-intercept form, it's very easy for us to find the y-intercept. The y-intercept is just going to be 0, whatever our value is right here. Let's finish off with one more example. We're going to go ahead and calculate the y-intercept for the line 0.2x minus 0.3y equals to 0.9. Remember that our strategy is, if we're trying to find the y-intercept, we are going to make the substitution of x is equal to 0, Once we do that, we're going to be left with negative 0.3y equals to 0.9. And we could finish off by dividing both sides by negative 0.3. This is going to leave us with y equals to negative 0.9 over 0.3. Remember, when you're working with decimals like this inside of a fraction, we could multiply both the numerator and the denominator by powers of 10, or in other words, we could shift the decimal in both the numerator and denominator at the same time. So our y is really equal to negative 9 over 3, which is negative 3. Of course, if you used long division and did 0.9 divided by 0.3, that would be okay as well. You should end up with the same final answer of negative 3. All in all, we can say here that our y-intercept is 0, negative 3. Alright, my little epsilons, stay positive.